Okay, today we're going to look at the rule for the area of a circle. So if we have a look at this circle here, we can see that it's split into 4 quadrants. We're trying to find the area of that circle. How much space is taking up inside? So what we're going to do is we're going to work with a partner. The partner's going to have the same circle, but we're actually going to draw this box around it, and I'll show you why in a moment. Now, the key thing to remember is you only have one highlighter. If you actually have 2, kids actually will start filling out both circles and they'll get lost. So, what we're trying to do is establish why the rule of the area of a circle is what it is. So, we ask the first person, the person with the square, to fill in 5 boxes. So they just quickly fill in 5 of their boxes. The person with the circle then takes the pen and they do the same. Now just beware that this isn't quite a circle, so they might choose to do this one. 5 whole boxes. Sorry, not quite a square. Alright, this person then, 5 more. And you can see that this person could get carried away if you just had 2 highlighters. They hand the pen over. This person, 1, 2, 3, 4, 5. Now we go back again to this person. 5 boxes. This one, 1, 2, 3, 4. Now we might go, oh, I'll do these 2 bits. So that almost makes a square. Alright, this person now, colours in their 5 small boxes. This person, 1, about 3/4. Do that bit as well. 2, 3, almost a whole one. Need a little bit more. I'm going to go over here and steal this bit. 4 and 5, that's about half a box. I'll do this one over here. Okay, so now we go back to this person. 5 more. Let this person colour in their 5 first. Then we stop and we talk about this. What has this person coloured in? They've actually coloured in, if I was looking at this area, the area of this would actually be side times side. And they'll tell you that. The area of this is side times side. Side times side. And then I ask, how could you say that differently? And they'll say, well, you could say side squared. And I'll say, taking into account that this is a circle, what do we actually call this line? And hopefully they'll come up with radius. So then we say, well, the area of this is actually the radius squared. Okay, then we come back and we say, okay, we've filled in 1 radius squared. Let's do another one. So once again, 1, 2, 3, 4, 5, and back it comes. 1, 2, 3, 4, 5. Swap the pen. 5 here. I'll just get quick and messy here. 1, 2, 3, 4. Once again, I'll do these bits to make a 5. 1, 2, 3, 4, 5. 1, 2, 3, 3/4. A bit more. 4, 5. Pen comes back. 1, 2, 3, 4, 5. 1, 2, 3, 4. 3/4. Oh, a little bit. 4, 5. I think I might have miscounted then. Anyway, 1, 2, 3, 4, 5. 1, 2, 3, 4, and I'll do 2 halves. 5. Back we come. 1, 2, 3, 4, 5. 1, 2, 3, 4. Almost a whole one. Let's go this bit. 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, we come to a stage we're not going to be able to fit 5 more in here. So we actually just get them to say, well, that's about 2. Okay, now we've filled up our circle. So we ask, how much did it take to fill our circle? Well, it took 3 of these. And we said one of these was radius squared. So a circle, the area of a circle, is in fact 3 times the radius squared. But then we say, well, hang on, what about this bit? It was a little bit more than 3. I always use the language 3 and a bit. But we can't have a rule that says 3 and a bit times the radius squared. And somebody very clever at some stage worked out that this bit was actually about 0.14. So about a bit more than a tenth, 14 hundredths if you like. And if you look here what they've coloured in, it's about a tenth of that square, not quite. And then we go, so if this is 3 plus this, we've got 3.14. And ask if anybody has seen 3.1 before, 3.14, and hopefully you'll get somebody say, isn't that pi? Yes, it is, because this isn't exactly 3.14, it's actually 3.14 and a whole lot of other numbers, and we use pi. And there is a button on your calculator that says pi, and show them how to use that. So we can say, if we use 3.14 times the radius squared, or pi times the radius squared, then we'll have the area of a circle. And that's how the rule is proven. The area of a circle is pi times the radius squared. Good opportunity to also tell them here that we don't use the times sign when we're using variables, so it would actually be reverse. Area equals pi r squared, and that's your area of a circle. Hopefully when we do this, kids actually understand why the rule exists.